All right, in this video, we are talking about histograms and percentile ranks, okay? So a histogram is a graphical display that uses bins to show the distribution of data. So the key word is these are bins, and it's a distribution of data, okay? It's easy to see the shape and how the values are spread apart, and you can see different clusters, you can see gaps, and you can see if it's skewed left or skewed right. So what I really wanted to emphasize is the difference between a bar graph and a histogram, because at first sight they look the same, okay? The key to note is that a bar graph is split up into different categories, right? The categories of eye color, and typically there's a gap between them, okay? Now normally when we make bar graphs we don't always put a gap between, but technically there should be. So then a histogram is different, okay? The y-axis is representing the frequency. And then down here, it's like a range, right? So this bar goes from 145 to 155, and the frequency is 2. So that means there are 2 students whose height is between 145 and 155 centimeters, okay? And then this is a bin, okay? And we decide how the bins should be broken up, and they just decided that it's going to go by 10, okay? And notice there is a break in the graph right there. That means they didn't do an even amount, right? They didn't start at 0 and then count by tens until they got there. They kind of did a little break so they could compare just their data, okay? So we're going to create a histogram based on this data, and we're going to divide the data into 4 bins. So the first part of doing a histogram is figuring out like how much I need to spread out my bins. And you figure that out by looking at your data. What's the minimum value of your data? What's the maximum value of your data? And how can you kind of split that up? So the minimum of my data is 1, and the max is 15. But I want to split into 4 bins. So how about I go up to 16, and then I can evenly space my bins, okay? So these must be equal sizes. Okay, they have to be equal size bins. Just like on a normal x-axis, we have to count by equal increments, okay? So I'm going to say right here 0 typically, 4, 6, 8, wait, no, sorry, I'm counting by 4s, not 2. So 4, 8, 12, 16. Okay, so that contains my minimum data point and my maximum data point. And then over here is going to be the frequency. So that means how many data points do I have within that range? So I am going to count by 2s. Like that. Okay, so now let's look at our data. How many values do I have that fall between 0 and 4? Well, I've got 1 and I've got 2. I have 2 values that are between 0 and 4. Okay, the histogram doesn't tell me what those values are. It just tells me that there are 2 between 0 and 4. So then next between 4 and 8, so it'd actually be between 5 and 8. I've got 5, 6, and there are 2 of each. So I've got 4 data points that are between 4 and 8. Again, it doesn't tell me what those values are. It just tells me that there are 4 of them. Then between 8 and 12, how many values do I have? Well, I have 9, 10, and 12. So I have 3 data values between 8 and 12. Okay, and then lastly, how many do I have that are between 12 and 16? Well, I just have 1 value, and that value is 15. Okay, so again, it's frequency. It doesn't tell me anything about the number or about the specific numbers. It just tells me how many are within that range. So I could do it differently. I could have divided it into 8 bins. Again, still thinking like something that's divisible by 8, 1 and 16, then I am going to be counting by 2s. So 2, 4, 6, 8, 10, 12, 14, and 16. Okay, and I'll keep my frequency the same just so we can kind of compare. Okay, so now this time my first value is how many of my data points are between 0 and 2. Well, I have 1 and I have 2. So there are 2 values between 0 and 2. How many values do I have between 2 and 4? So that means 3 and 4. Well, when I look at my data set, there's nothing there. So I would have 0. Okay? Then between 4 and 6 would be like 5 and 6. So I have 1, 2, 3, 4 values that are between 5 and 6. Oh. Okay? And then between 6 and 8, which would be like 7 and 8, I don't have anything. So again, I'm going to put like nothing there and put a 0. And then how many values do I have that are between 8 and 10? Well, I've got 9 and 10, so I have 2 values. How many values do I have between 10 and 12? Well, I've got 1 value. And then how many do I have between 12 and 14? So it would be like 13, 14. Well, I have none, so I'm going to put 0. And then lastly, between 14 and 16, I have, what should I use? 10. I have 1 value between there, okay? One value. Okay, so you can see how kind of the distribution looks different depending on how many bins I have. For a more accurate measurement, I would have probably chosen 4 bins, because then I have less bins that are 0. So pause this video, take a minute to sketch this histogram, and then press play when you're ready. So check your histogram against my histogram, see if it looks similar. I could have done a break in the graph and started at 20, but it's not that far from 0, so I just counted by 10. And then I did the frequency or the number of people. So next we're going to talk about percentile. It's the percentage of data values that are below a given value. Okay, so how many data values are below your given value? Okay, so here's one example. I have test score A. Okay, there are 30% of the total scores are below my score. So that means I am in the 30th percentile. Okay, because my score is better than the scores of 30% of the tested students. So you may have seen your percentile in the MCAs, things like that. Okay, similar but kind of different language. Let's say test B. I am in the 80th percentile because my test score was better than 80% of the people, or because 80% of the tested students have scores that are lower. Okay, so you're always looking at what is below, what percent is below. So the difference between the percent on your score and your percentile rank is that the percent score expresses the number you got correct, so your actual score. So if you got like 96 out of 100 on a test, you got 96 points out of 100 points, you got a 96% score on your test. But that doesn't mean that you are in the 96th percentile. Okay, you have to then compare your ranking. How do you rank compared to other scores? So how many people scored below you? It's the number of people that scored below you. So for an example, if 2,000 people took a test, 300 people scored the same or better as you. So let's kind of think about this as over here represent the low scores and over here represent the high scores. Kind of thinking from left to right like an axis. So if 300 people scored the same or better than you, then you are ranking like, you're like the 300th person in ranking of, you've got the top 300 score. So then how many people are below you? There are 1,700 people then that scored worse than you did. Okay, so to get that then percentile, you take the number of people that scored below you out of the total number of people that took the test, and that means that you ranked in the 85th percentile. So 85% of the people that took the test scored worse than you, or you scored better than 85% of the people that took the test. Okay? So example 2, if your doctor tells you that your height was in the 75th percentile, what does that mean? Okay? That means that you are taller than 75% of the people in your age and gender group. Okay, you're the 75th percentile, there are 75% of the people are less than you. So let's kind of pull this all together and do this big problem, okay? So the first thing that it says is the data is used in this histogram to have a mean of 34.05 and a standard deviation of 14.68. Okay, so the first thing says to approximate the percentile rank of a value 2 standard deviations above the mean. Okay, so what I need to do is I need to find 2 standard deviations above the mean. What is that number? So if one standard deviation is 14.68, then to get 2 standard deviations, I'm going to do 14.68 plus 14.68, right? That's one standard deviation and then another standard deviation. So when we add those together, we get 29.36. An extra decimal there. Okay? So now that's 2 standard deviations. And now I want to know what's 2 standard deviations above the mean. So if my mean is 34.05, then, need some more space, I'm going to do 34.05 plus my 2 standard deviations, 29.36. Okay? And when I do that, I get 63.41. Okay? So it's saying approximate the percentile rank of a value that is 63.41. So let's estimate. How about we just estimate that that's exactly at 60 for easy sake, just for estimation. So now we want to see how many people scored less than that. So if we looked at these frequencies, this is 2, this is 4, this is probably about 5, this would be 9, this would be 4, 4, 3, 3, 2, 1, 2, 0, 1. What is the number of test scores that are below that? Or I guess, I don't know, I'm thinking test scores because that was our previous example. Well, I have to add up 2 plus 4 plus 5 plus 9 plus 4 plus 4 plus 3 plus 3 plus 2 plus 1. There are 37 scores or data values below the 60. And I'm just estimating 60 because I don't want to try to split that in half. Okay, so I'm just going to give my best estimation. So then I need to know how many total values there are. So then I would do 37 plus the last 2 and 1. So that means there are 40 total values. So I just do 37 out of 40. So 60 is in the 93rd percentile. I guess I should write the word. Okay, so 37 divided by 40 gives me 0.925, and then convert that to a percent and then round up. It would put in the 93rd percentile. Okay, so that's the answer to the first question. Okay, how many scores are below that? There are 37 scores below that score. I keep thinking scores, but that's not the context. I'm just going to put it in that context. There are 37 data values below that value. Okay? So then the second one, approximately what percentage of data values are within one standard deviation from the mean? So what I want to do is I want to look at like what is the minimum value that I could be within one standard deviation of the mean. So I take my mean and I subtract one standard deviation. And when I do that, I get 48.73. I'm sorry, 19.37. Okay, so this would be like my minimum. That's one standard deviation less than the mean. And then I find one standard deviation greater than the mean. So I add 14.68. And when I do that, I get 48.73. And this would be my max. Okay, so let's approximate to about 20 and 50. I want to figure out how many values do I have between 20 and 50. So 20 is here and 50 is here, right? How many data points do I have in between there? So we would go ahead and add up 5 plus 9 plus 4 plus 4 plus 3 plus 3. And when we do that, we should get 28. So there are 28 values out of the 40 total values that are between 20 and 50, just given an estimation, which means 70% of scores lie within one standard deviation of the mean. Okay, so you kind of want to think about like what you want over the total. Okay, or how many data points are there over the total, just like how we normally calculate percent.